In this video, we will be solving some basic logarithmic equations. The first thing that we'll be doing is writing the equation in exponential form. Our first example is solve the log of 16/9 base x equals -2. Now when we write this in exponential form, we know that the base of the logarithm is the base of the exponent. So x is the base of our exponential. Also, we know that the log is the exponent. So -2 is our exponent. And then this is equal to the argument of the logarithm. So x to the -2 is equal to 16/9. Now, in order to solve this, we'd like to find x to the first power. This means that we need to raise both sides to the reciprocal power. The reciprocal of -2 is -1/2. So I'm going to raise both sides of this equation to the -1/2 power. Now, whenever we have a power to a power, we multiply those exponents, and when we multiply -2 times -1/2, we get a +1. So we have x equals 16/9 to the -1/2 power. Now I'm going to take this in steps. Let's first get rid of this negative exponent. We know that a negative on the exponent will turn this upside down. So the 16 will go down to the denominator, and the 9 will come up to the numerator if we apply this negative exponent. So this gives us 9/16, and now it's just raised to the 1/2 power. Recall that whenever you have a fractional exponent, the numerator is the power and the denominator is the index on the radical. So I have a square root. The square root of 9 is 3, and the square root of 16 is 4. Now be aware that whenever you square root both sides, like at this point, you would normally have plus or minus on your answer. But since we are finding the base of a logarithm, the base of a logarithm must be a positive number. It's by definition. All right, our next example, we're asked to solve the log of x base 16 equals 3/4. Again, we're going to approach this problem by writing it in exponential form. The base of our logarithm is 16, so the base of our exponential is 16. We know that a logarithm is an exponent, so this is the exponent on our base. And then that's equal to the argument, which is x. Now this fractional exponent is the same as the 4th root of 16 and then cubed. And we could also write this as the fourth root of 16 to the third power. But I want to check and see if the fourth root of 16 is something that I can do. 16 is the same as 4 times 4, and then 4 is 2 times 2. So we can see that 16 is 2 to the fourth power. So I'm going to do this fourth root of 16 without raising this to the third power. That would be a really big number. So the fourth root of 2 to the fourth power, and then that number cubed. Well, when you do a root and a power that are the same, those are inverse operations, so you end up with just the radicand, the number that's underneath. So this is equal to 2 cubed. So we can say then that x is equal to 8. Right. My next example. Again, we're going to approach this by writing as an exponential. The base of my logarithm is 36, so the base of my exponential is 36 as well. We know that the log is the exponent, so x is my exponent, and then my argument of the logarithm is what this exponential is equal to, so square root of 6. Now what I'd like to do is get the base on both of these to be the same. I'm going to need to make this 6 to the second power. So I have 6 squared raised to the x. And then I'm also going to write this as an exponent. Remember that the index on this radical is a 2. So this is the same as 6 to the 1/2 power. Whenever we have a power to a power, we multiply those exponents. So 6 to the 2 times x is equal to 6 to the 1/2. Since these are equal and my bases are equal, then my exponents must be equal. Therefore, 2 times x equals 1/2. To solve for x, I multiply both sides by 1/2, and x is equal to 1/4.